more and more in the same exact amount of space. Everyone that's out in the field knows, hey, we got a 750 plant, got a 750 plant, I can't stretch it. I mean, that's just physics. I mean, 750 plant, you start rolling off if you try to go above that. Remote PHY and all that, we're talking about going to 1 gig, we're segmenting everything closer, trying to get more and more bandwidth. But in the meantime, we have millions of miles of plant out there, and we're trying to make this stuff work. And some of the stuff that we're doing here, the MPEG-4, is saving us that bandwidth. It shrinks it. Every time you compress it, a group of pictures is basically when you see a group of pictures, it's an iframe on both ends and a couple iframes in between, but there's these predictive and bidirectional frames in between that are only changing, like John was saying, they only change the information that is there that needs to be changed. If I'm looking at a still picture like all of you, I'll just see the heads that are moving basically. But all the chairs, all the background, all will stay the same. Those are those predictive and bidirectional frames. That saves us bandwidth. That's the idea of compression. So our ultimate goal is to keep more and more compression, and that a logarithm that needs to do the compression consumes a lot of power. There's a lot of intelligence into that stuff. So that's how we've gotten into this phase now. I mean, we're talking about gated the HTTP format, and that saved us even more bandwidth in a sense. It's more complicated than I'm describing, but it's at the end of the day, it's all savings. And the problem is that the more and more we compress it, the more and more we have to have analytics to be able to see, to make sure that picture is seamless to everything. So with that, we're going to start going over a few slides here of our own. So Lucas, you want to go to the first couple slides?
So as we've been saying, there's a lot more data, and it's not even really video anymore, it's data, and there's a lot of it. Lots of log entries, hundreds of thousands of devices, billions of transactions daily with considering every button click with X1 is a transaction. Obviously the volume is extremely large, and there's just a lot of data there to cover and to correlate. So metrics versus logs. Metrics being alarms and alerts that can come from all of the devices from the source to the set-top box. So all of that is collected, so the costs for metrics is lower. It's very fast for queries, sorry, I lost my place there. Alerting, so stuff we would use even like Spectrum, right? So alarms coming in, alerts that would alert the technician that there's something wrong and that somebody else would need to go dig into a problem deeper. And then the logs, which we would use for troubleshooting, there's a lot of entries in logs, and it takes a lot of space. It's very expensive, but it gives you a lot more detail. So the alert comes in, maybe it's a buffer issue, a bit rate issue, or something with a specific device. It may not tell you what service it is or what a MUX or anything like that, but it would allow you to go dig through the logs and find out specific information, specific data that would point you to the exact problem. So we are using a lot of open source tools now. Grafana, Elasticsearch, Logstash, Kibana, and Tableau, and these are all mostly visualization tools. So all of this data, the millions and millions of data points we collect, can be represented graphically so that a person can look and see, where a problem may be coming in. And a lot of the stuff that you're going to see in the upcoming frames will show you, it's a lot of graphs minus some of the details of the axis and the specific numbers, but it is representative of what we're doing with all of this data. So this is just a high-level overview of kind of how we get from point A to point B with source and transcode, and we haven't even gotten into recording. I think we've been talking all about straight linear video so far, when we all know that a lot of the stuff that we watch, and I know me personally, I almost never watch live TV. I'm watching recorded content. So there's that part, packager, CDN, and the player. So, this is source monitoring. This is a picture of the Tektronix Sentry that we use almost exclusively for our source monitoring. Just showing that the quality of experience up at the top here is good.
So just to expound on the quality experience. Now, I know you guys, we did talk about quality experience, but in the layman words is that the quality experience is what they see on TV. So we always are striving for that 100. So if you think there's no line there, but there is. It's 100%. You see how it's 100%? That means we're seeing a good picture. That's the experience that you guys are seeing. The quality of service is different. That is just measuring the fundamental packets of the transport. So it's only saying, is there any fundamental errors in the transport stream? Like, am I getting continuity errors? Am I getting, do I have jitter? Do I have all that kind of stuff? Which will ultimately affect, mostly, sometimes it doesn't, but it can. It will affect the quality of experience. So they're both needed. Just the quality of experience is something that the customer sees. That's a customer view. So we know that the customer saying, if I got 100%, that means over a span of time, we have 100% quality experience. So I know that they're seeing a good picture. Now, we might see some continuity errors in here, and we might want to dig into that a little bit later, but that's the underlying issue that could come bigger.
And alert. Great. So, yeah, and the quality of service is getting from point A to point B. The quality of the experience is the encoding. Is the encoding good? Is the levels good? So this is the transcode, and this is a Grafana dashboard, and this is taking metrics from the transcoder. So the transcoders are capable of providing a lot of the same information that the Sentry does, with just basic bit rates, memory usage, CPU usage. The CPU usage alarm, you wouldn't see anything on the source, but obviously on the transcode output would lead to problems. And this is more of the same kind of metrics with continuity count, PID errors, some of the same 101, 290 alarms that Tektronix and all of the vendors do with quality of service. And some more bit rate, PCR jitter, all of the same alarms, but now showing up in a dashboard in Grafana where you can be able to correlate data, kind of more data from more points. So the packager is the next step in the process. And this is kind of just a dumbed down graph of, I'm not sure which one this is. I want to say this is errors on packagers across all of the packagers. And this will be indicative of something that was fixed at some point in time.
All right, so you can see here where there's a spike of errors, and then we found the resolution, and then it settled itself down, so the packagers weren't having so much of an issue.
And then one of the other tools that one of the gentlemen on Viper Ops generated was the ability to review the content post-packager. So before, once it came out of transcode, we monitored with the Sentry, there really was no way to look at that video unless you had a client able to pull that stream. And with all the digital rates management and the way cloud works, you basically had to have an account in that area associated with the specific controller and authorized properly to be able to stream anything post-packaging. We now have the ability to watch that content in very short 3-minute segments without having to have any rights management or anything. So it at least gives us the ability to validate stuff coming out of the packager before it gets into IPCDN and further downstream. Mr. Pillow. Mr. Phillip. On into the recorder. So this is just a graph representing day-to-day number, like I think it is number recorded.
This
Yeah,
is requests and that's
requests
successful
and
recording.
successful recording. So you can see every night how the volume of the recording content goes up. And as you can imagine, it is, when you record, the recorders are taking everything from the transcoder. So all we talk about, 4 or 5, however many representations you have for a service in IPTV, they are all being recorded out of the transcoder. So obviously there is a large amount of volume being recorded and played back. And you can see here that it is quite a large number. And this is, I think, in a day, and you can see here between, this is about 6 p.m. on through 11 o'clock, just the, how it's a factor of 2 or 3 here, or more than that, of the volume of content. So Dash Origin, we talked about it a little bit. And this is day-to-day. Sorry, it's difficult. I've had to remove some of the labels on the axis. Yeah, day-to-day, it's a day-over-day request, I believe. So you would see here a couple of points where obviously something was going on. This would be an incident where someone would have to go investigate what was going on. So off into the content delivery network. So this is actually this is a daily graph with showing bandwidth and the number of connections that are in use over time.
So these are the people actually pulling stuff off of our content delivery network, which is all IP. So this is, you can see the representation on the amount of connections that we have in a given day. And again, the access has been removed of it for obvious reasons, but you can see all that type of stuff. And like what this one here is talking about is the daily bytes, terabytes served, and then monthly petabytes served. Now I'm not talking about we're not talking about gigabytes anymore or terabits. We're talking about petabytes. We're talking about a lot of data. So you can see how much stuff is being used every day.
Over time, from starting in 2016, so 3 years ago, you can see kind of when we started to where we are recently. Things have increased in volume significantly. That's not going to change. I'm sure it's probably going to increase continuously over time. And then the player. Error code. So the X1 set-tops are constantly sending data back, and we frequently get escalations from ViperOps saying that they've detected like tune errors on a specific source ID in a specific area. So this would be a graph that is representing error codes from set-top boxes and the number over time. And a bunch of squiggly lines.
So I got a question about
Yes.
that. What you just said, that the box is sending you back messages of errors. Can you elaborate on that, or what type of errors that it's seeing? Or is it a plant issue that it's seeing?
Could be. It could be a lot of different things. So they have,
The box, the new X1, we have a lot of data coming from a lot of different data.
Right.
And the set-top box is a computer, obviously, it's decoding stuff. So it has the ability to basically have certain stuff that we can get back. And that information is discernible by you know, again, without trying to get into the weeds of how we do business, I guess, the data we had before was minuscule compared to now. So we can really get data all the way from each individual set-top box.
Such as like a Nielsen rating of what they're watching, or?
Then I can't really go into that.
Yeah, okay, I got it.
But specific source ID, so if we know that they're trying to watch, you know, ESPN or whatever the program is, and they try, and it's tuning by source ID. If they try to tune that source ID, and it could be a QAM issue, right, a problem with an APEX or an SG or whatever, or they have a bad cable feeding their house or whatever it is. If they go to that frequency in that program and the box doesn't decode a signal,
Right.
that would be a red flag. And so if they collect enough of those from the same controller ID or the same, you know, something with in common, that would be, that's an opportunity to let somebody know that, hey, you might have a problem with this program in this ad zone or whatever it is.
So does that drive like an algorithm in the watchtower or something to flag a fault? Based
no,
on what it's coming back?
It's higher than that. I think it's more. I think somebody is looking at like one of the Grafana graphs and seeing something and kind of drilling down into it and seeing if they can find something in common. And frequently it is a source ID or a group of source IDs, and they would escalate that to us at the XOC saying, you might want to check this out.
And there's a standard group of alarms. So the alarms, Spectrum, everyone knows what Spectrum is. I mean, it's a tool out there that manages, that pulls in alarms. So I mean, all these Grafana, all these open source tools that we use, Grafana, you know, and all these, they're query tools. So we have customized queries that we use that using this open source tool that takes that data and puts it into a graphical representation for us. So really what we're seeing here, like in these screens, is when we talk about set-top, like how many sessions we have. So we know how many sessions we got because we have that information coming in. We also know how many, you know, how many failures we have, because that's another alarm. I mean, every piece of equipment out there we have today has alarms in some way. They're called MIBs. So this is basically a MIB down to the most granular level you can get, which is a set-top box. Something that we never had. And this is what makes it such a challenge. This is something we've never had before. We've never been able to measure all the way down to the set-top box level. We've never been able to do it until now.
Right.
So that is why there's a challenge with the monitoring that we have today. And there's also a lot of proprietary things that go on with this type of monitoring. But it gives us that ability now to go to the lowest common denominator, which is your CPE. And that gives us more forecasting. It gives us more trending data. And a lot of this stuff that we're seeing today is trending. We'll see spikes in alarms. All the traditional stuff we had before is still in place, but we need something more. We need more. So now we're talking about trending, and we're talking about how granular can we get this stuff to give us those errors. You know, it's not going to tell us a specific source ID failed per se, but it'll tell us that this box is having an error or whatever happened. But it's giving us a new wealth of data to help make sure all of our customers, no matter who we work for, is getting the most quality service. Because again, the end of the day is to make sure, like John was saying, everything's seamless. You guys, for all you guys know, you think this is still MPEG 2 stuff. You guys don't know what's MPEG 4. You definitely don't know it's Dash or HLS. That's the key, and this is the stuff that helps us get this done.
Sure.
Yes.
Has there been any consideration of putting like a sort of transponder for active devices to be able to monitor like network points rather, because you're pulling off of CTE, talking about finding common points based on their ad zone or however it's broken down. Is there any concept of putting something like at an active location that can pull these errors that might be able to tune through the channels and break it down that way?
So,
Well, so
Like from a field perspective, you're talking about?
Right.
I don't know anything that
well,
we did
so
from a field
we do
perspective.
have,
In our
there is
network.
one tool that isn't really around anymore, although we do have it, Volacon, which,
That's
yeah, it's a CPE, but it is So Volacom is no longer around as a full company, but they made a product that took a set-top box, the HDMI output, into basically an encoder, and it had intelligence into it, where it could decode the screen. It could tell a black screen from color bars, from active content. It could look at closed captioning. It could look at audio loudness, and it would do the channel. It was your daily channel check device, and it just constantly was going through a cycle, and it would go channel by channel. It would see if there was content there or not. I mean, it was kind of the end, but
That was more for a source. So the Volacom unit, which we do use today, it was more of a source acquisition. I think what you're talking about is the Volacom would come back and say, okay, I am going to do it as a video engineer and operations manager. I want our team to make sure that everything's working good at a source level, and then if there's no problems and so on and so forth, you know, Ed and his team would be doing all the node granular levels at the node. But I want to see the overall how a particular DMA, you know, like a geographical area. When I say DMA, think of broadcasters or sports. Those little zones there. I want to see how those things are working. And that's what Volacom is really good for. I think what you're talking about is making an access point of saying, you know, the old school mentality is, you know, split the stuff in half until you guys find where the problem's at, you know? And I think am I hitting the nail on the head?
Generally, yeah, if there is an issue, it can point out like the whole area being affected.
Right.
Of one common source.
Right, but you're talking something more granular or more downstream of the hub or head end itself, right?
Right.
Okay, so digital rights management comes into mind right after that. So right now, which is encryption, okay? We can only do so much stuff in a QoS world. We can say, okay, the fundamental streams aren't working, but we can't actually start doing that QoE where we start seeing, you know, nuances that, you know, Chronic's call about, like I got a tired picture, I got this and that, some that a lot of you guys you know, have to deal with on a daily basis. So, no, the answer is no, we don't have anything like that. And I'm not, you know, it's a thought, because we do that for, you know, power supplies and stuff like that today, where we have transponders and power supplies sending back metrics all the time.
The impression I got from the first presentation, right, with the R5 stuff was that obviously if you can adjust the levels without measuring speed, right, then you're doing that, you know, through some sort of communication with it. So at that point, you have to assume that you're going to get logs and metrics back from the hardware in the field as well, right?
Right. So remote PHY is a whole other world. So remote PHY right now is very, it's less than 1/10 of 1%. Okay, it's very, very small. I get it; it will grow in size. But yes, remote PHY gives us the option with all the same open source tool that we use today, specifically more like Grafana or whatever. We would be able to query all of those data points that come back. Because again, the key word is MIPS. Everything has a MIP, so it's going to send back all those alarms and everything that you need. And you just got to basically tell it what MIPS you want to see. And then we query all that stuff and put it into a visual tool or a data set that we can pull that data from. And to Philip's point, that would be the end game for us to say, hey, at this parent node, I have all these errors coming out or whatever it is. And then I know that this parent node affects XYZ child nodes. Okay? So that is your kind of your split in the middle type of thing. But again, technology hasn't, remote PHY is new. It's very, very new.
Yeah, today the best we have is CPE, right? And something like what you were talking about with Watchtower, right? Is if you can kind of plot some of that out based on what the CPE is. But you can't say specifically that this amplifier is causing the problem, right? You can make some assumptions, right? But you don't necessarily
Educated assumptions.
And we don't,
We'll get
yeah,
down by the CPE.
but even today, we don't have the data set of amplifiers and field gear associated to the video network, the video gear, the video, unless somebody is manually trying to look at two different places at the same time and match things up. But there's no way to do that now. I mean, I have, a long time ago when X1 first came out, I said, well, if it's a computer, why don't you build an X1 box and do calm testing for me? I mean, why do I have to sit there and go manually clicking through a whole day's worth of video content to find commercials to look for loud spots but, I mean, AI and whatever, I mean, build that into a set-top box, and just put set-top box in the head end, where you need to test and have it do its thing. Easier said than done, but possible. I mean, that kind of stuff is possible, and we're just starting to get our feet wet and really getting access to a lot of this data and trying to marry it up and build these queries and figure out the best way to kind of dig through them.
There is a such thing as too much data, so that's something that we're running ourselves into today, is that we have such a ocean.
Many tools.
Ocean of data.
Many tools.
And so many tools that do so many things, and they're good tools. Every single one of them are good tools. But you start getting to a point where, you know, we want like this, something to say, okay, this thing is right here, this one screen, just say for example, this one's going to tell me everything I need to know, okay? And using the right amount of data at the right time, at the right place. That's what our end goal is. But the exponential shift in technology today, and I mean it by exponential, it's a rocket ship we're going through right now. We're overwhelmed, you know, and we're taking all this data today and we're really building it up. And like again, this transcends Comcast. This is every cable company out there. We're doing all the same thing. We're trying to make sure that we get the right data in the right place for the right viewers at the right time. I mean, that's really what the end of the day is. And as Brian was saying, we're just getting our feet wet on this stuff. I mean, it really is. We're in a new world. In the old cable world, this is it's a very exciting time to be in right now. It's just it's crazy. Our brains are thinking again. You know, dusting the cobwebs off. This is good times right now. Lots of opportunities for people.
So we got a couple more things here. I think this is be like something for a single user CPE kind of log, and that was it anyway.
So I want to. There's like I said, we've talked about a lot of stuff here today, and this is just a touch of tools. And I really wish we could give you guys a more numerical based information. But again, it's something that is that we have to keep proprietary, obviously. But I think everyone here has got an understanding of that how we do things yesterday is different than we do today, and it really is. It's really about the customer experience. Everyone here wants a great customer experience. We're trying to do everything to see the problem before the problem happens. And all of these tools here are one of those things. All these tools here are all linked to some sort of, has an API in it which we can forward off to make tickets with other open source tools that we're using and so on and so forth. So that's the end goal, is because we don't want that customer to get down that phone. And that's, we don't want that truck, to roll that truck. And the more information we have to find the problem, the better off we're at. And we are continually, for now and then for several years to come, trying to evolve all these tools that we have, that we can get to that point. Contrary to before, back in the old days, as and those tools we have that John was talking about, the Tektronix Sentry and the InnoQuest I was referring to in Volcon, that gave us, that was so far upstream that we would miss things every once in a while. I mean, it's natural. You can only look at so much stuff. And monitoring, unfortunately, is extremely expensive. So it's not something that's cheap. But that's where I get to. You got a question?
So yeah, I happen to work with some of the technicians out in our R5 platform here in Gwinnett, and they kept mentioning this tool, Grafana.
Yes.
And I wonder if you could elaborate on how they're utilizing this tool and why it's effective for them in the field.
So Grafana is really, again, this is an open source tool. Grafana is a query tool, okay? So it takes alarms or data points from our stuff, and basically we use we program what the query is. The query is just, we're asking for data. So we say, all right, if this data point comes out, I want you to grab it and put it on the screen, okay? And I don't know, can you go back to the Grafana screen?
So it's an open source tool that's basically using an open source database. And it is,
Go back to that first.
You want to see it?
Right there.
I'll go to the other one.
I want
Oh, I
One more.
That one right there. Get there when you start.
Okay, so this is Grafana here. We're using this for something else on this aspect. But this gives everyone that we tell it what data set to pull, and then we put it on a screen. So now all the field technicians go out there and they say, all right, where's the laser pointer?
What are you looking for?
So they can sit there and they can say, okay, I'm looking at this particular RFI node. I can see all of what's going on in each node. And this is, to me, to say, okay, I got myself a first starting point. I know what to look at now. Because I'll say, how many modems I have online? Well, they put a graph in there saying how many modems they have online. And those, what's that?
And by time, right?
And by time.
By time.
Yeah, so you'll have the time underneath here or whatever it is. But it tells you how many it's got. So they can see if there's a precipitous drop right around here, they can say, okay, at this particular time there was an event that happened.
Okay.
And they don't have to dig through the mountain of data that we have. It's all been, it's querying all of that stuff and putting it on the graphical representation. If they want to get into more detail, then we have other tools to help them get into more of the details.
So would this be a proactive tool? I'm going to use that in the event of an RFI outage, as compared to looking at Watchtower. In other words, is this more real time than Watchtower would be? Would this be something they would look at?
So so Watchtower obviously is a tool that we use, obviously, and it does have, Ed, you're here. What's the time delay on Watchtower? Put that on the spot here, he wants me to.
Yeah.
You can't talk about it, right? Okay, so it could depend on if Ed's, doing whatever Ed's doing. That's good. I love Ed, he's a friend of mine. So, but Grafana is real time, but there is always a delay on everything. But what we want to do is that, Watchtower has its value. Trust me, there's great value in Watchtower.
Right.
I mean, it really.
Yeah, I didn't want to discredit that tool.
No.
but-
I get what you're saying. But yes, this is a real-time tool that we get. As alarms come in, these things pop in here. And then there's APIs that are associated with it that we can pull out and do things with that data.
And it's predefined. I mean, if you guys said, hey, we notice whatever the metric is, whether it's something to do with modems and asked, and I guess we'd have to ask the right people, but an RFI is kind of new, but that's something that could be developed, right? If you have a metric that seems to pop up every time you have a specific problem, we certainly could ask to have that built and monitored. I mean, there's a lot we can do to be proactive with these types of tools. We do a lot of it already with a lot of other things in Spectrum, but there's no reason we couldn't do the same thing with all this other stuff.
It's all scalable.
Versus
Yeah,
Watchtower.
absolutely.
It's all scalable, right? So I mean,
Yeah.
depending upon how frequently you want to hit the device, right? It's really, if we're speaking specifically to RFI, right? There's no reason that our field equipment can't be like our network equipment is, right?
Right.
And we have an understanding of the health all the time, right? But depending upon how quickly you want to pull it and how quickly you want to, save all that data and all of that stuff, right? And you get to the point that it's all based upon, what are your resources essentially to manage that amount of data.
Yeah, like even some of the new meters they're putting on the trucks to test for leakage and sweeps and stuff, right? From what I understand, like, you guys will be driving down the street and ding, ding, it already knows where you are, and it's hey, there's a leak here, and I mean, like, there you go, right? You're right over there fixing a problem,
You have to walk
I
like
mean,
that.
yeah.
Well, no, that's what he has. He's got the big pole in his hand, trying to find that leak. That's good.
But certainly, there's a lot of opportunities with all of this new technology to
I
make
think
this
it
work.
goes to what you opened up with, is metrics versus logs. As far as like Watchtower is great for metrics in real time. You can look at history, but digging into specific historical views, it's a little bit more difficult. Where Grafana has a very detailed picture on more of a historical plot line, I would say.
Yeah, it's
Better
kind of
for
the real
logs and
time
traffic.
versus, hey, something happened, last week at, 5 o'clock on Friday. Can you go figure out what it was? Can you give me a root cause? Because we get a lot of that too.
Yeah.
I think artificial intelligence helps us there as well, right? Because you can start to, as you analyze the logs, right, because you've got that detail, and you can almost start to build like a,
Predictable algorithm.
an example, right? Yeah, so this happens, then this happens, then this happens. And so to Tektronic's point, right, that's hard when it's coming like that, right? For somebody to analyze it. With artificial intelligence, then you can start to build like this use case that, hey, every time I see this, I need to do this, right? And so it's identifying the trends and being able to, kind of highlight those, right?
It's a challenge because it's like, it's not the traditional video.
The actual sheet.
Right? It's data.
Page out to 2 for an average.
Yeah.
It's the Jetsons.
Yeah, the day of the video
But it
engineers
would
has
improve our
changed, right? It's really more
audit
computer
process.
science based stuff today.
Based
than it
on-
is- I mean, we still have a lot of video engineers inside our company, right?
Which is 15 minutes to
That analyze video.
Take over.
There's a lot more people who know a lot less about video actually doing video.
Correct.
For sure.
Anyone else got any questions? Ed, you had a question?
On a separate note, with the cloud PVR, so like streaming recordings, is it kind of the same thing? It breaks it down into the 2 to 5 second clips?
Yeah. So out of the recorder, it goes into a packager and gets processed in very easy.
Now, is it possible for, like, 2 neighbors record the same program? Each one of those is saved as a separate file,
For a certain period.
Yeah, I was gonna say, it's only for a while. You can't do that for everybody. That's a legal thing. That's not something that is,
You talking about a remote fine?
again, it's for a certain period of time. And it's a little bubble.
No, would it be possible to have like 100 people in this area record the same program?
Yes.
And save that as a shared?
Legally, we cannot. So that legally, we have to give everyone their own individual copy because they own it.
You can if they have the same checklist. I think that was the legal.
I don't know.
After a certain period of time.
Yeah, the legal
I don't know.
jargon was checksums match, and they're the same.
After a certain period of time.
But we all know that checksums,
If 1,000 customers want to.
never, I mean, that's not gonna happen.
I'm not saying it
I
might
mean,
not
if
be.
it's off by a millisecond,
The
check.
RPD board.
So it's interesting stuff. Yes. So anyone else any questions? I mean, you guys got questions about, video in itself other than monitoring? I mean, that's also, feel free to ask. Yep, go ahead.
How's digital rights management handled when you're not talking about set-top boxes? When you're talking about phones and tablets, when you're outside of the MSO network?
So, Phillip, you got an answer for that one?
It's the same, right? Because it all talks back to the same server, right? So DRM is the same whether you're inside. Now, there's a validation to make sure that you're on your network, right, when you're in your house, but for like TV everywhere, it's the same.
So it, like I said, references your account to see where you live, so when you look at.
Well, yeah, you already logged into your account, right? You're gonna.
So that's what it uses for geographical location.
But it also registers your IP though.
Yeah.
Well, that's what I'm saying. You have to
You're
go
on
on your
home
gateway
network.
if you're in your house.
You
but
can't-
this
you can't
question
stream
was on
outside the
TV.
house.
Oh, so some things, yeah, some things you can't stream when you're outside the house, kind of thing.
Yeah, and that's all legality is the reason that we do that, right? It's not like it's a technical issue. It's just really make sure that you have it anywhere. But, from a legal perspective, right, the contracts that we have with the contract providers, right, is what dictates what we can have where. The actual, the process of getting the key to the encrypted is.
Any other questions? Ed? Ed, you had a question? All right, well, thank you guys, everyone, for hearing us today. I appreciate it. If you guys have questions, and if anyone wants to sit in with any of the video engineers, they want to learn more about video,
Yeah.
reach out to Phillip Adams. He'll be more. You can reach out to me. I'm again Mark Wildermuth. You can reach out to me, and we can sit there. We can maybe have some shadowing time with some of my engineers. So if you guys feel that need, please reach out to me, and I'll be more than happy. Obviously, Comcast. If you guys have that desire, please reach out to me. I'll be able to accommodate.
Non-Comcast people, contact me.
That's not Comcast.
As long as you have a PO, right? As long as you have a PO.
Not me.
Great. Well, fantastic. I'd like to thank John Bradford of Electronics for coming out and sharing their information today about how to monitor and test the IP video streams within the networks that we have today. Very useful information, very pertinent with what's going on in our industry.
Thank you.
So, thank you very much. Really appreciate it. Speakers from Antronics earlier today, Rob Crowe, for sharing with us RPD and advanced architectures and next generation architectures. So this is going to conclude our session for today. A few final housekeeping items before we release you and let you go. If you did get into the room without signing up, please see Carolyn and get your name on the roster. Once again, make sure you use the name that you used to sign up with the SCTE. And if you are a member of the SCTE, which I hope everybody in this room is, please go on to the SCTE site and go into your personal information and make sure that you're signed up to be a part of the Chattahoochee chapter because we found some instances here where people's membership renewals occurred and their affiliation with the local chapter got dropped. I think Mike Cooper in the back of the room, I was sitting there reviewing the roster of Cox employees last week, and Mike was sitting beside me, and I didn't see his name as being a member of the Chattahoochee chapter. And I said, well, I know you're a member of the SCTE, you know, what's going on? He actually logged on, and basically the information of the affiliation for the chapter wasn't there, so he had to go back in and edit that. So if I could ask you to do that, we'd greatly appreciate it. Our next event is going to be our Vendor Day and Golf Tournament, August 28th and 29th. It will be at the Marriott Conference Center at Stone Mountain Park. We had a great turnout last year. We had 288 golfers sign up. We actually had to start turning people away because the course couldn't handle any more golfers. So if you want to join us, you want to play golf, please sign up early. It's a fantastic event. The day prior to the golf tournament, as I said, it'll be vendor day. A lot of the vendors will be coming up, setting up tables and displays in the conference room. And that will be followed that evening with our dinner and awards celebration. Right now we have some guest speakers lined up. It will be Kevin Hart, who is the Chief Technical Officer and Chief Product Officer. Not the comedian. That would be great though. But Kevin is the Chief Product and Technology Officer at Cox Communications. And along with him will be a couple of his SVPs. Guy McCormick is the SVP of Engineering for Cox, and Rob Smallwood, who's the SVP of Outside Engineering and Construction. It's going to be a little bit more Cox focused this year. We want all the Comcast, Charter, and everyone else there as well. The last couple of years, we had a lot of great speakers from the Comcast executive team in, so this year we're just going to mix it up a little bit. I think it should be a great event, and we look forward to having everybody with us. So,
What did you say those dates were?
August 28th and 29th.
Thank you.
28th will be the vendor day, followed by the dinner that night. The 29th will be the golf tournament. Stone Mountain Park, beautiful golf course, and great backdrops with the mountain in the background, so it's really a great day. Sadie, Carolyn, Krista, anything that you want to add from the board standpoint? Yes, thank you so much for your attendance. We really appreciate it. So have a great day, appreciate it, and we'll see you soon, hopefully at Stone Mountain Office. Oh, yeah, my family. Sorry. I got a long drive, so I got to do it.